We want to use the properties of logs to write each expression as a sum or difference of simple logs. In other words, we wish to expand this expression. So we begin by taking a look at the argument, which is 3y to the fourth divided by x squared. So first we see that we have division. So when you have division in the argument, that can be rewritten as the difference of two logarithms. In other words, that would be equivalent to log base 3 of the numerator of the argument, which would be 3y to the fourth, minus log base 3 of the denominator of the argument, which would be x squared. So our first step is rewriting it as the difference of these two logarithms. But now we take a look at the individual arguments again to see if we could use our properties any more. So taking a look at my first argument, which is 3y to the fourth, we notice that this is really 3 times y to the fourth. So we actually have a product. So now we can continue and use our product rule for logarithms, which says when we have a product, we can actually rewrite it as a sum of two logarithms. So that would be log base 3 of 3 plus log base 3 of y to the fourth. And then we still have minus log base 3 of x squared. So now we've rewritten the original as the sum of two logarithms and then a difference as well. So we now have 3 individual logarithms. And now we just want to see if we can simplify these any further. So taking a look at the first logarithm, log base 3 of 3, I'll do this over here off to the side. A few ways of remembering how we could simplify log base 3 of 3. One way is to say, I don't know what this is equal to. I'll just call it some unknown. I could call it question mark. And that means I'm looking for 3 raised to what power will give me 3. And we know 3 to the first power is 3. Therefore, this logarithm is equivalent to 1. If you don't like that explanation, let me give you another one, just another reminder, that when we have a logarithm where the base is equivalent to the base is equivalent to the base in the argument, we know that these will undo each other and we'll be left with whatever the exponent is here of the argument. So that's that inverse property. Another reason why log base 3 of 3 is just going to be equal to 1. And then moving on, we see that my next logarithm, the argument is y raised to the fourth power. So the power property for logarithms says that we can actually rewrite that as multiplication. So that 4 would be in front and be multiplied by the logarithm, log base 3 of y. And likewise, for my last logarithm, since the argument is x raised to the second power, again, the exponent could come in front and be rewritten as multiplication. So that would be minus 2 times log base 3 of x. So this would be our expanded answer. 1 plus 4 times log base 3 of y minus 2 times log base 3 of x. B is the natural log of the cube root of x plus 1, all divided by e squared times the quantity x minus 2. This one looks a bit messy. But same directions. We want to see if we can expand this into several logarithms that are either added or subtracted to one another. So we have a pretty messy argument, but we'll begin with seeing that we have division in this argument. So we know our division can be rewritten as subtraction, 2 logarithms subtracted. So this is going to turn into the natural log of the numerator, which is the cube root of x plus 1, minus the natural log of the denominator. And the denominator is the e squared times the quantity x minus 2. So our first step is to rewrite the original logarithm as the difference of 2 logs. And now we'll look at these logarithms individually and see if we can apply the properties any further. So we know that the natural log of the cube root of x plus 1 could also be rewritten as the natural log of x plus 1 to the 1/3 power. And in doing this, then we realize that the argument is raised to a power, so I could also use my power property and rewrite this as multiplication. So that would be 1/3 times the natural log of the quantity x plus 1. And now we move on to the second logarithm, the natural log of e squared times x minus 2. So we notice in this logarithm, I have a product here in the argument. So I know that this product can be expanded into addition, or the sum of two logarithms. So that would be the natural log of e squared plus the natural log of x minus 2. However, I have to be careful because I was originally subtracting this logarithm. So because the original logarithm here that I'm highlighting, the natural log of e squared times x minus 2, becomes these two logarithms being added to one another, it's imperative that I am subtracting this entire quantity here in red to draw your attention to this. So I need to subtract essentially both of these logarithms. In other words, this will end up being distributed. So in the end, I'll actually end up with minus the natural log of e squared and another minus the natural log of x minus 2. So both those logarithms will end up being subtracted in the end. And then I continue with my properties of logs and a couple of ways of simplifying this middle logarithm. Okay, I'll show you both ways. One way, if you wanted to use your property, would be to realize that your argument has an exponent, so we can rewrite that exponent as multiplication. So this would be the same as 2 times the natural log of e. But then remembering that natural log really means log base e, and my argument is also e, so I have 2 times log base e of e. And this piece here, log base e of e, is actually equal to 1. So essentially I have 2 times 1, which would just be equal to 2. So this middle logarithm, the natural log of e squared, is actually going to be equal to just 2 when we simplify it. But you may not like that explanation, so let me show you an alternative. Instead, another way of doing this middle logarithm here, would be just rewriting your natural log as log base e, and realizing that my argument is e squared, and then using your inverse property of logarithms. Whenever the base is the same as the base of the argument, then these are going to undo each other, and we realize that we'll be left with the exponent. So this is equivalent to just plain 2. That would actually be the shorter way of justifying this. Alright, so now, putting that all together, my first logarithm I can't do anything with, and the reason why I cannot use any additional properties on this log is because the argument contains addition, and we don't have any properties of logs that help us with addition in the argument. Minus, my second logarithm is actually equal to just 2, and then minus the natural log of x minus 2. And once again, I don't have anything that I can do with my last logarithm here because the argument contains subtraction, and we don't have any properties of logs with subtraction in the argument. And this would be my expanded form of the original.